Let's look at the solutions of modern math bites. A coin is biased such that the probability of head turning up when the coin is tossed is 3 by 5. What is the probability that exactly 3 heads turn up when the coin is tossed 5 times? This is given by 5c3 into 3 by 5 cube into 2 by 5 square, which turns into 10 into 27 into 4 by 3125. Cancel 2, cancel 625, gives me 216 by 625. Answer should be option C. Next, a die is biased such that the probability that it rolls a 6 is 1 by 5. And the probability of rolling other numbers from 1 to 5 is equally divided among them. So for these 5 numbers, combined probability is 4 by 5, and each of them have equal probability. So 4 by 5 or 1 by 5, or each number has a probability of 4 by 25. If this dice is rolled twice, what is the probability that the sum of the numbers turned up is 10? In order to get a 10, you need either 6, 4 or 4, 6 or 5, 5. So probability in the first case is 1 by 5 into 4 by 25. In the second case is the same thing. So I do into 2 here. 5 by 5 is 4 by 25 into 4 by 25. So let me do this so that bases become same. So this turns to 625, 5 into 4 into 2, 40. This gives me 16 by 625. If I add both of them up, I get 56 by 625, or option D is the answer. Of the 180 people in a room, 120 drink tea or coffee. The number of people drinking Pepsi is 5 more than the number of people who drink coffee. The number of people who drink Pepsi and tea but not coffee is 50. Lots of information given. Let me just record it in a Venn diagram. Okay, of the 180 people, tea, coffee, Pepsi. Of the 180 people in the room, 120 people drink tea or coffee. Okay, these regions at the top add up to 120. So these two regions, people who are part of only Pepsi and people who don't like any of the stuff, they together add up to 60. The number of people drinking Pepsi is 5 more than the number of people who drink coffee. So if the number of people who are drinking Pepsi is X, number of people who are drinking coffee is X minus 5. The number of people who drink Pepsi and tea but not coffee is 15. Okay, this region here is 15. The number of people who drink none out of tea, coffee, or Pepsi is half the number who drink only tea and coffee. So if only tea and coffee is 2y, none is y, and only Pepsi will therefore be 60 minus y. Okay. 20 people drink Pepsi and coffee. These two regions add up to 20. Okay. 50 people drink tea. 50 people drink tea. 135 people drink at most 1 out of tea, coffee, and Pepsi. This is an interesting piece of information because when they say 135 people drink at most 1 out of tea, coffee, or Pepsi, people can either drink 1 drink or 2 drinks or 0 drinks or 1 drink or 2 drink or 3 drinks. They're telling me these two groups add up to 135. So these two groups should together add up to 45. There should be 45 people who are drinking either 2 drinks or 3 drinks. The groups of people who are drinking either 2 drinks or 3 drinks are these 4 groups. These 3 groups at the bottom add up to 30. So, add up to 35. So 2y should be equal to 10, or y individually should be equal to 5. If y is individually equal to 5, only Pepsi should be equal to 55. If only Pepsi is equal to 55, can you see total of Pepsi? 55 plus 15 is 70. 70 plus 20 is 90. So people who drink Pepsi is 90. So people who drink coffee will be 85. If people who drink coffee is 85, 10 people are mentioned here, 20 people are mentioned here, 30 gone. So there are 55 people who drink only coffee. Okay, now look at this. The entire circle of Pepsi is 90. Add this 10, you get 100 people. Add this 55, you get 155 people. Add these 5, you get 160 people. The only people who are not accounted for so far out of the 180 are the ones who drink only tea. And how many will they be? 160 people are accounted for. So this has to be 20. As soon as this is identified as 20, within T, see there are 4 regions. 20 plus 10 is 30, 30 plus 15 is 45. But T was supposed to be a total of 50. So this is 5 and this is 15. Now we have all the regions, all the numbers, everything is available to us. Let's get to individual options. Which of the following statement is true? First one, the number of people who drink only coffee is equal to the number of people who drink only Pepsi. Yes, this is valid. I have 55 here, I have 55 here. But I cannot mark A as the answer because there is also an option, all of the above. So let's go to option B. The number of people who drink all 3 beverages is equal to the number of people who drink none of the 3 beverages. Yes, this is also true, 5 and 5. At this time, I'm confident I can mark D as the answer. But for peace of mind, we'll also look at statement C. The number of people who drink only Pepsi and coffee is equal to the number of people who drink only Pepsi and tea. Yes, this 15 and this 15 is identical. So the correct answer has to be option D. Next, if 4 lines are drawn in a plane, find the maximum number of overlapping regions the plane could be divided into. Okay. There is a formula for this, but I don't want to get into the formula because deriving that formula is going to be difficult. On the other hand, there are only 4 lines, no? You can always work with 4 lines and get to your answer very easily. Here, just ensure that the points of intersection of all pairs of lines are distinct. Let's count the regions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here you will have your 11th region. How many regions? Answer is 11. The general formula for this is n into n plus 1 by 2 plus 1. How this formula is derived is also not geometrical. It is algebraic in nature. You do it for 1 line, you do it for 2 lines, you do it for 3 lines, you do it for 4 lines. Then you see a pattern emerging and then you come up with a generic expression for that. This is not geometric in nature, but okay. Okay, next thing. An urn contains 1 green hat, 2 white hats, and 3 black hats. Hats are drawn at random, one after the other without replacement. What is the probability that a black hat is drawn before a white hat? Okay. We have 1 green hat, we have 2 white hats, and 3 black hats. If we are looking for the probability that a black hat is drawn before a white hat, out of the hats that are drawn, either the first hat has to be black and then this condition is fulfilled, or if the first hat is green, the second hat drawn has to be a black hat, then this condition is fulfilled. These are the only 2 cases I have to take care of. What is the probability that the first hat is a black one? It is 3 by 6. If the first hat is a green one, 1 by 6, the probability that the second hat is a green one is 3 by 5. So we get cancel, 1 by 2 here, cancel, 1 by 10 here. So we get how much? Half plus 1 by 10, or altogether 6 by 10, or altogether 3 by 5 is the probability. In case you are looking to make unacceptable cases, you can also make it this way, white being the first one, or green being the first one and white being the second one. White being the first one, probability is 2 by 6. Green being the first one, white being the second one, the probability will be given by 1 by 6 into 2 by 5. This is 1 by 3. This is 1 by 15. If you add these up, you get 16 by 15 or 2 by 5. But remember, these are the unacceptable cases. So your final answer will be 1 minus 2 by 5, which is equal to 3 by 5. You can choose to go down any path. Both ways, you will get the same answer. That is all for this episode. Hopefully you learned something. Okay, bye.